All right, let's look at this first one. When you're doing these, you're going to start with your numbers. What can I do with numbers? And then you're going to go to your x variable and then your y variable, and you're going to go to each variable and simplify them individually. All right, so for this one, I only have a 4 as far as numbers go. It's not being multiplied by anything except 1, really. So my 4 is not going to change. So I automatically know I'm going to have a 4 right here in front. Then I'm going to look at my x's. So I have x to the negative 1 times x to the negative 1. And then I am going to look at my y's. I have y squared times y to the negative 1. And so if I were you, I would write it out this way, because you're going to make simple mistakes if not. And then I just simplify each piece of this. My 4 can't simplify, so it stays. For my x's, I add these exponents. I have negative 1 plus negative 1. What is that? X to the negative 2. Negative 1 plus negative 1 is negative 2. And then I'm going to look at my y's. I have 2 plus negative 1. What is 2 plus negative 1? Positive 1, right? And so I have y to the positive 1. All right. Then we have a negative exponent. What do my instructions tell me specifically? To leave all of my exponents as what? Positive. So that x to the negative 2 is going to go in the denominator position. It means that the other guys are going to stay up top. 4 and y will stay in the numerator position. The x will go to the denominator position with a positive 2. And then I am done with this particular one. And that is my answer. 4y over x squared. So just like I did for this last one, I am going to look at the numbers. Then I am going to look at the variables, okay? And so for my numbers, when it's division, what I look at is, can I reduce? Can I reduce 4 over 3? Is that reducible? It is not. So it's going to remain a 4 over 3. My numbers are actually going to stay exactly the same. Now remember, with division, I subtract, all right? So before I even subtract, I'm going to decide where it's going to end up. So I'm going to look at my u's, and I have u to the 4th over u to the negative 4th. Which one is bigger, positive 4 or negative 4? Positive 4. Where is it located, numerator or denominator? Numerator. So I know my u is going to end up on the numerator position. That is going to always stay where the larger exponent resides. Now, determining what my exponent is, I use subtraction. So I have u to the 4 minus negative 4. What is 4 minus negative 4? 8, because it's plus a positive 4. And so this tells me I have 8 in the numerator position. So that is u to the 8th. U to the 8th. Let's look at my v's. I have v to the negative 3 and v to the negative 3. Which one is bigger? They're the same. Anytime they are exactly the same, you're going to get to the 0 power, which means they cancel to a 1. And so my final answer here, my u's went to the 8th power and my v's canceled out completely. And so my final answer looks like this: 4u to the 8th over 3. Anytime they're the same, they're going to cancel out. Negative 3, those are the same exponent. They cancel to 1. And so I'm just multiplying the top by 1 and the bottom by 1. Well, if you multiply by 1, it's just what it is, okay? If one's larger, then that's going to tell you where it's going to end up, numerator or denominator. But if they are the same in division, they will cancel. If they are the same, they will cancel. I want to point out a couple things on this first one. You have some positives and negatives, and you have a 0. Also, you have a negative in the very front of your fraction line. This is the most common mistake all the way up to like my calculus kids. When there's a negative in front of that fraction, the whole entire fraction is negative, and nothing in this is going to change it to positive. Okay, those negative exponents will not change it to positive. Your answer will be negative here, okay? Because it is negative to begin with, and there's nothing to reduce out of it to change it to positive. So when you see this right here, you need to go ahead and mark your answer as negative, all right? Your answer will be negative. Then we're going to look at our numbers just like we did on the other one. Can I reduce my 2 and my 3? No, I cannot, so that's going to stay. I'm going to look at my A's. I have an A to the second power and an A to the 0. Where's my A going to end up? Top or bottom? Top. And then I have A to the 2 minus 0 because I'm subtracting, right? So it's on top to what power? 2 minus 0 is 2, okay? Let's look at my B's. I have B to the negative 1 and B to the negative 4. Which is bigger, negative 1 or negative 4? Negative 1 is bigger. So this is going to end up on top as well. And then it is B to the negative 1 minus negative 4. What's negative 1 minus negative 4? It's plus a positive. So it's positive 3. Negative 1 plus 4, right? Negative 1 plus 4. So that is 3. I'm done. So once you've reduced your numbers and you've gotten all of your variables to just one, I have one A, one B. I don't have multiple in multiple places, right? Then I have simplified it. And I am actually done with this one. My answer here is negative 2A squared B cubed over 3. That is my answer here. All right, so let's look at number 20. I have a group to a power, a group to a power. It means everything in the group needs to be taken to that power. So I'm going to take 3 to the third power. I'm going to take A to the third power, and I'm going to take B to the third power. The only thing I really need to simplify here is this 3. What is 3 to the third power? 3 times 3 times 3? It's 27. 27A cubed, B cubed. So anytime you have a power to a power, a group to a power, everything in it is taken to that power. And I do a little more complicated one next. So you can see, as I said, they're building. This is now combining multiplication and power to a power, all right? And so I'm going to take this one group at a time. One group at a time. I am going to actually leave this first part alone, and I am going to simplify this group. And then I'm going to combine my like bases, all right? One thing I will say is I'm going to write this as negative 1 in front of that x. I'm going to write that as a negative 1 in front of that x. So I'm going to leave the negative 2y to the fourth alone. And then I'm going to take each thing in this group to that third power. So I have a negative 1 to the third power. I have an x to the negative 3 to the third power. And I have a y squared to the third power. All right. Again, I'm going to leave that negative 2y to the fourth alone for right now. Negative 2y to the fourth. I'm going to simplify these. What is negative 1 cubed? Negative 1 times negative 1 times negative 1. It's just negative 1. Remember, if you have a negative to an odd power, it's going to stay negative. If you have a negative to an even power, it's going to change to positive. And then you just have to worry about what the number's doing. 1 to the third power. Well, that's just 1. So this guy is going to reduce to just be negative 1. All right. What do I do here? A power to a power. What do I do with these? You multiply them, right? When it's a power to a power, you multiply. So what is negative 3 times positive 3? Negative 9. All right. Then let's look at the y. I have a power to a power. What do I do here? Right, 2 times 3 is 6, all right? Now I'm going to combine my like bases, okay? I have coefficients here, so negative 2 times negative 1, I'm going to multiply those, all right? which gives me what? What is negative 2 times negative 1?
2.
Positive 2. I cannot combine my x's with anything, so that is just x to the negative 9th. And then I have y's, y to the 4th and y to the 6th. Y to the 4 plus 6, right? Okay, everybody see what I did there? I can't combine my x with anything. He stays x to the 9th. I have 2 y's, so I add those exponents, all right? I have a positive 2. What happens to the x to the 9th? Where does he go? On the bottom. X to the 9th on the bottom. What about this guy? It becomes y to the what? 10th, and it's positive, so he is going to stay on the top. So my final answer for this is 2y to the 10th over x to the 9th. Over x to the 9th. All right, so I want to point out something. I have a negative, right? So I have a negative, and nothing in here is going to change it. Now, I had a negative on this one, but something changed it, this negative, right? Here, nothing is going to change it. I don't have a negative inside that group being taken to a power. I have nothing else that's going to change that. So I automatically know that my answer is going to have a negative in it. All right, I automatically know that my answer is going to have a negative in it. All right, the first thing I'm actually going to do is I'm going to simplify this group. So I am going to leave the 2m squared alone, and I'm going to simplify this. How do I simplify that m to the negative 4 to the 3? I multiply. What is negative 4 times 3? Negative 12, all right? So let's look at my numbers. 2. Can I simplify that 2? No, that is just how my answer is going to be, with a 2. All right, let's look at my m's. I have a positive 2 and a negative 12. Which one's bigger?
2.
Where's my m going to end up? On the top, right? So I'm going to have an m here. I actually end up having nothing on the bottom. This is m to the 2 minus negative 12. It is plus a positive, right? Negative and negative makes plus a positive. 2 plus 12 gives me m to the 14th. And that is actually my answer here. Right? I dealt with my 2. And I dealt with my m's. I kept my negative. Negative 2m to the 14th. All right. What do you notice about number 31? There's a negative in front, okay? And I will say we have another negative in the problem. We do. The other negative is here, but it is to the even power. So what's going to happen to that negative? It's going to turn to positive, so it will not affect this guy at all. If it had remained negative, you would have a negative, and they would turn positive, right? But in this case, you don't, right? So your final answer is going to have that negative in front of it. So I would actually go ahead and write that down. All right, you are going to have a negative. For this one, I'm going to leave the numerator alone for right now because I have a denominator that's more complicated, okay? So I'm going to just write this numerator the way it is and leave it alone. I'm going to deal with this denominator. Remember, this is a negative 1 in front. So the denominator looks like this. I have a negative 1 to the 4th power. I have an x cubed to the 4th power. And I have a y cubed to the 4th power, right? And so when I simplify this one, again, I'm going to leave that numerator alone just for a minute. Negative 1 to the 4th power becomes positive 1, right? What do I do here? X cubed to the 4th. What do I do with those? Cubed to the 4th. Multiply. 3 times 4 is 12, right? Same thing with the y's. 3 times 4, it actually is y to the 12th. All right? And then I'm going to simplify individually. I'm ready to simplify. 2 over 1. Does that simplify? No, it's just 2. Okay? It's just a 2. Let's look at my y's. I have a y to the -1 and to the 12. Where's my y going to end up? Top or bottom? Bottom. So it's going to be an x on the bottom. All right. Now I just have to figure out what. This is x to the -1 minus 12. By the way, when you have figured out where it already is, you can subtract the smaller from the largest, okay? Because if I do -1 minus 12, I am going to get what here? -13, which tells me the bottom, right? Tells me x on the bottom. Or you can always subtract like that. If you've already decided where it goes, then you don't need the positive and negative to tell you that. You've already decided that. So you can always subtract it smaller from larger if you want to. That's going to give you a 13, all right? But you've already decided where it's going to go. It's going to go on the bottom with a 13. You've already decided. So whichever way you need to subtract, you can subtract because you've already decided where it's going to be. Okay, when it's like this, when it's already broken out as a fraction, and you've already chosen, hey, it's going to go on the bottom, you can just subtract the two numbers the easiest way that you need to, okay? Same with the y's. If I look at my y's, I have a +2 and a +12. Where's my y going to go? Top or bottom? It's going to go on the bottom. So now that I've determined that, I can just subtract the 2 and the 12. What is 2 and 12 when I subtract them? It's a 10, right? 2 minus 12 is a -10. That actually tells me it goes on the bottom. But if I just subtract them, 12 minus 2 is 10. I've already determined it's going to go to the bottom with a 10. Okay, so once you've already decided where it's going to go, you can subtract either way. It doesn't matter. All right? But you can always subtract top to bottom or smaller to larger. It doesn't matter as long as you know where it's going to go when you actually put it down. This is your final answer. -2 over x to the 13th, y to the 10th. All right, and let's look at this last one. He's huge, and the entire group is taken to a power, all right? So I would actually simplify inside first, and then when I got that all down as simple as possible, then I would take everything to the third power. The reason is if I take everything to the third power now, I'm going to take a ton of things to a power, and then I'm going to have to simplify bigger numbers. Does that make sense? And so when it's the entire group taken to a power, I'm going to simplify the inside first to get it down to just my numbers and one of each variable, and then I'm going to raise all of those to the third power, okay? So I'm going to simplify the inside first. With this particular one, I'm going to leave the numerator alone for right now because it's as simple as it can be. And I am going to simplify the denominator. All right? So let's look at my numbers. -2 times -2. What's -2 times -2? +4. Let's look at my x's. X squared, x to the -1. I add those. What is 2? So I have x to the 2 plus -1. What do I have down there? X to the first power. All right. And then my y's. I have y to the -2, y to the third power. So I have y to the -2 plus 3 on bottom there. What's -2 plus 3? 1. Okay. And this whole thing is being taken to the third power. I still have more simplifying I can do on the inside. Okay, so let's look at just the inside. I have a 1 over 4. Can that simplify? No, it cannot. It stays 1 over 4. What about my x's? 3 and 1. Where's my x going to end up? It is going to be 2. And where? On the top or the bottom? Where's my bigger x? Top. So 3 minus 1 is 2, right? All right, let's look at my y's. I have a -2 and a +1. Which is bigger, -2 or +1? So y is going to be on the top or the bottom? Bottom. So negative 2 minus 1 is negative 3. But on the bottom, it's just going to be 3, right? Or you could say 1 minus a negative 2. Either way, it's a 3 on the bottom. 3 on the bottom. Now, this is as simple as it can be on the inside. And now I can take everything to that third power, okay? So now I can take the inside and I can take every piece of it to the third power. All right? So I have, and you can do the 1 if you want to, but you don't have to worry about it because 1 to any power is 1. On the top, I have x squared, and that is to the third power. On the bottom, I have 4, and that is going to be to the third power. And I have y cubed, also to the third power. So I've taken everything now on the inside to the third power. And so my last step is just to do these powers. In the numerator, I have a power to a power. What do I do with those? Multiply. So 2 times 3 gives me x to the 6th. I have 4 cubed. 4 times 4 times 4 is what? Yeah, 64, right? 4 times 4 is 16. 16 times 4 is 64. Okay? And then the last thing are my y's. I have y cubed, cubed. So it's y to the 3 times 3. So it's y to the 9th. All right, y to the 9th. And that is my answer. So even though it looks huge, you're going to take it one piece at a time. So notice the difference between these two. I had just one of my either numerator or denominator to a power. I did that first, right? But here I had the whole group to a power. I simplified the inside first, okay? Does that make sense? So when you have part of it to a power, do that first. When the entire thing is to a power, simplify the inside first and then take it to a power.